What makes a Python function truly robust when AI systems need to call it? You'll see how to implement proper input validation, like handling empty strings with strip, while maintaining clean type hints and documentation, exactly what DSPy requires for reliable tool integration.
Def good tool city. SDR units. SDR equals Celsius. SDR. Get weather information for a specific city. ARGS. City, the name of the city to get weather for. Units, temperature units, either Celsius or Fahrenheit. Returns, a string describing the current weather conditions. Hash implementation with proper error handling. If not city strip. Return error, city name cannot be empty. Hash weather logic here. Return F weather in city, 25 degrees unit 0, upper, sunny.
This demonstrates the DSPy tool function pattern, where a standard Python function becomes an AI-accessible tool through precise type annotations and documentation. The example shows a weather information function that uses parameter validation, default arguments, and structured return values to create a predictable interface. The key characteristic here is how conventional Python features like docstrings and type hints serve double duty as both developer documentation and machine-readable tool definitions. The pattern works by treating the function signature as its complete interface specification. The type hints define the expected inputs and outputs, while the docstring provides both human-readable documentation and context for AI tool selection. The implementation handles its own validation logic, like checking for empty city names, demonstrating how business logic remains encapsulated within the function while still being exposed to external systems. This approach matters because it creates a clean bridge between human-written utilities and AI workflows. The pattern solves the common problem of making existing functions AI-accessible without requiring framework-specific modifications. It's particularly useful when you need to expose domain-specific logic to AI agents while maintaining standard Python practices and keeping validation logic tightly coupled with the function's core behavior. Let's break it down line by line.
Def good tool city. SDR units. SDR equals Celsius. SDR.
This defines a function with type hints and a default parameter, creating a self-documenting API. The city SDR annotation enforces string input while units SDR equals Celsius provides a sensible default, eliminating the need for optional parameter handling in most cases. The SDR return annotation makes the output type explicit for both developers and static analyzers.
Get weather information for a specific city.
This is the function's one-line summary in the docstring, following Python conventions. It appears in help, output, and IDE tooltips, giving developers immediate context about the function's purpose.
City, the name of the city to get weather for.
Documents the city parameter in the function's docstring, specifying it as the required input for the city name. This provides clear parameter documentation for developers and tools that read docstrings.
Units, temperature units, either Celsius or Fahrenheit.
Documents the valid string literals for the units parameter, restricting it to either Celsius or Fahrenheit as indicated in the docstring. This provides clear usage guidance without runtime enforcement.
A string describing the current weather conditions.
Specifies the function's return type in the docstring. This tells callers they'll receive a formatted string describing weather conditions, matching the actual return statement's format.
Hash implementation with proper error handling. If not city strip.
This checks for empty or whitespace-only city names using strip, which removes all whitespace before validation. It's a standard defensive programming pattern to prevent processing invalid inputs.
Return error. City name cannot be empty.
Early return for input validation. The strip check catches empty or whitespace-only city names, immediately returning an error message to prevent processing invalid input. This defensive pattern ensures the function fails fast with clear feedback.
Hash weather logic here. Return F weather in city, 25 degrees unit 0, upper, sunny.
This is the function's response template that combines the city name with formatted temperature units. The unit seer, upper, dynamically capitalizes just the first letter of the unit's parameter, ensuring clean output like 25 degrees C or 25 degrees F, while the placeholder, 25 degrees, sunny, simulates what real weather data would provide. DSPy tool fundamentals. The goodTool function demonstrates the essential pattern for creating DSPy-compatible tools, using Python type hints and a descriptive docstring to define the interface. The implementation includes basic input validation to reject empty city names through a simple strip. Check. This pattern of typed, documented functions with minimal validation forms the building block for all DSPy tool integrations.
The tool call execute holds the answer before react's trajectory completes its reasoning.